Today, here's your lesson. How to roll over. You can roll over. Come on. Oh, that was sad. Push. All right, we found enough. All right, guys. Hope you enjoyed my daughter trying to do her morning workout, roll over, trying to get strong. All right. Anyways, here's the lesson for today. It is on the last review learning target called Molarity and Dilutions. Yay! We're going to talk about what happens when you add like a solid to water, what's the process and how to calculate what we call molarity. So what is a solution? A solution is when you have a solute, which is usually a solid, dissolved in a solvent, which is usually water. Now, this also could be like a solvent, could be oils too, whatever. So, and then we get a resulting solution. So a solute is what's being dissolved. A solvent is what's doing the dissolving. Here's what dissolving actually looks like. So let's say you like a solid is usually made up of positive and negative cations and anions. So let's just say this is sodium positive and chlorine negative. So it's an ionic bond and it is held together by the charges. Well, water, when it comes in, this is water. Well, water has a, if you remember back to your honors chem, it's polar. It has a negative side of the molecule and has a positive side of the molecule. And what happens is the positive side matches up with the negative, and ultimately what we get is we get these molecules or these atoms surrounded by water molecules, and vice versa. The positive side would go, or the negative side would go to the positive side. So that's just kind of how it all works. Opposites attract and it pulls it apart. Obviously, if you let something like evaporate, the water evaporates out and then the ions go back together. So that's the process there. So molarity. What is molarity? Molarity is a way to measure concentration. We talk about moles. So like moles is just a number, which is the number of molecules or atoms in a substance, and then liters of solvent. So this is your base equation, moles over liters. From that, we can deviate a little bit. Here's your base, moles. If I'm given grams, which is a pretty practical thing, like, hey, you have grams of salt. What's the concentration if you dissolve this much? Well, we can convert to moles, and then vice versa, we can also convert from milliliters to liters. So if I have something that's 16 molar, which basically all it means is it's an expression that you have 16 moles, so 16 times 6.022 times 10 to the 23rd atoms in 1 liter, which is a lot, which is a ton actually. So that would be a uh, very concentrated solution. Concentration just refers to how many molecules are present. So if you think you're making Kool-Aid, if you have a very concentrated Kool-Aid solution, there's a lot of molecules in there of sugar. 1 molar just would mean that you have 1 mole for every 1 liter. All right. So how you do that is you basically just say, okay, if I had molarity is equal to moles per liter, well, if I have 0.461, okay, so molarity is equal to 0.461 moles divided by 1.32, you will get your answer that way. So that's how you do that. We'll talk about how you convert to grams from grams and milliliters in a second here. So here we go. Copper sulfate, CuSO4. All right. So here's what I want to find. I want to find the molarity. I have to be in moles and I have to be in liters. All right. So I'm given 12.9 grams and 418 milliliters. Well, I got to convert that to liters and I kind of convert grams to moles. So how I convert from grams to moles is I go 12.9 grams of copper sulfate, and I got to go to moles of copper sulfate Okay, 1 mole. Basically, it's the first bracket of stoichiometry. It's just because it's a molar mass conversion. 1 mole, and then how many grams? I'll look it up here. 150, I just usually Google molar mass. 159.609, so 159.61. 0.61 grams. Okay, and then whatever you get from this answer gets plugged in there. And then if I'm going from milliliters to liters, I divide by 1,000. So that's 0.418, or excuse me, 0.418 liters. And that goes there. And that'll get your answer. So you have to be in moles and you have to be in liters to be able to solve for that. Same thing here. If I want to figure out the molarity of this solution, all right, well, I have 2.5 grams in 3.2 liters. So what I have to do is I just got to convert grams to liters. 2.5 grams of NaOH. And how many moles is that? Well, there's 40 grams. I know this one. Over 1 mole. I just looked it up, added NaO and H together. That answer gets plugged in there. You also may be asked to solve for grams. So you are given a concentration and you're given milliliters. So I'm given 2.5 molar. I want to figure out, hey, this is the solution I want to make. It's 0.20 liters. I just converted that. I got to solve for moles first. And once I solve for moles, then I can go to grams. My bracket will just be flipped. So it'll be grams and 1 mole on the bottom. And then that'll be my answer there once I do my conversion. So I solve for this, plug it in there, do my conversion from here to here, and then that'll be my answer there. Okay, so I just got to look up the molar mass potassium carbonate, which is K2CO3. Alrighty, so that's the gist of molarity. We'll talk about dilutions now. So go ahead if you want to pause. All right, so now we're going to talk about dilutions. So dilutions is taking a solution and making it more dilute by adding more solvent. So let's just say you had a glass of Kool-Aid. All right, you got a bunch of Kool-Aid molecules floating around, and then we all know what happens if you add more, put in a bigger glass and add more water. You might have the same amount, but there's more water. So essentially, what you do is you just call what we dilute it. So adding solvent doesn't change the amount of molecules you have in there. All it does is just add water and lower the concentration essentially. So this is our base equation. M is molarity. Okay, initial. So 1 means it's initial, and then molarity final. And then this is volume initial, and this is volume final. And these can be in milliliters or liters, it doesn't matter as long as it's the same for both. It has to be the same for both. So if I have a 2 molar solution, okay? If I have a 2 molar solution, I want to make a 1 molar solution out of it. I want to dilute it to 1 molar. Here's kind of the process. So M1 V1 is equal to M2 V2, all right? Basically what we want to find out is how much of this do I need, and then how much do I have to add, and then add water to get to 1 molar, right? So if I had a 2 molar solution, how much of that V1 do I need to get to a 1 molar solution times 100, all right? So what I do then is I just take 100 divided by 2, which is 50 milliliters, okay, of 50 milliliters of the stock. This is what we call the stock solution. And then, well, to get to the 100 milliliter volume, the final volume, I'm gonna need 50 milliliters of H2O. Okay, so basically what you do is you cut it in half. So you just cut it, right? Here's another example. If I have, there's just different ways to word these problems. If I have a 340 milliliter 0.5 molar sodium bromide solution, what will the concentration be if I add 560 more milliliters of water? So your M1 is 0.5 molar times 340 I want to figure out what the final concentration would be if I add 560. So 560 plus 340, that's going to be the final volume. That's 900 milliliters. So essentially what I do is I just divide by 900. Okay, M2, what's my final concentration? You can do the math, which is 0.188. So that is the final concentration of that. Okay, so the hardest part is figuring out what variables you need, where they plug in and where they need to go. Um, but once you figure that out, should be pretty good. How many liters of a are needed to prepare? This is the solution you want to make, and this is your stock solution. So I have a 2 molar times V1 of it, and I want to get to a zero point 0.4 times 0.250. Okay, so solving for V1 is going to get you how much you actually need to get to that liter volume. Okay, so V1 ends up being 0.50, I believe so. 0.50 liters of stock, and then I would need 0.200 liters of H2O to get me to that final volume. Okay, so that's the gist of all that. Um, Okay, so what you're going to do now, guys, is just finish up your packet. Make sure you check your answers. Last lesson on Monday, I'll post, or later today, I'll post a information uh, on your test. I posted it for on for it's you don't have to do it till Monday. If you want to do it over the weekend, um, feel free to. It shouldn't take you too terribly long. Um, But yeah, so that's really it. That's your last review lesson. Work on that, complete the attendance form, and that is your 5 learning targets for uh, a review lesson. Yay! Your test will be posted. I'll post that, and then just make sure you watch this walkthrough video. So, all right, guys, peace.